Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 8G assignment. First one we're looking at, without using a calculator, find log of 10,000. So really what this is asking us is 10, because really it's log base 10, so log base 10 of 10,000. So they're asking us 10 to what power equals 10,000. Okay, really all we're going to do is count the zeros. 1, 2, 3, 4. 10 to the fourth equals 10,000. Okay, so without a calculator, find log of 10,000. It's going to be 4. Okay. Same thing for log of 10. So that's 10 to what power? Let's see. So this, sorry, back over here, x equals 4. 10 to what power gives us 10? Guess what? That's 10 to the first power equals 10. So that means x equals 1, whereas x equals 4 over there. Okay? Okay. Number 3, explain why log 237 must lie between 2 and 3. 10 to the second power equals 100. 10 to the third power equals 1,000. Guess what? 237 fits in between that. That's why it's got to lie between 2 and 3. So it's got to be 2 point something or other. Okay? Okay, use your calculator to find log of 83. So we will do that and simply just hit log 83. The nicest questions they'll give you all year long in this here. 1.91. The 9 tells the 1 to get bigger, so let's call that 1.92. Okay, hence write 83 as a power of 10, where the power is rounded to 4 decimal places. Would have been nice if they had told us that up there. So there's our decimal, so 1, 2, 3, 4. So that 7 tells the 0 to get bigger, so it's 1.9191. So let's turn this into 1.9191. So that means 10 to the 1.9191 should equal something pretty close to 83. Okay, and just to show you how that works, we can do this a couple different ways. Well, let's just do the 1.9191. So 10 to the 1.9191 gives us 83.004. So look at that. It works. Magic. Okay, that was that one there. Number 8, use your calculator to write the following in the form 10 to the x, where x is correct to 4 decimal places. So what we want to do here is just like what we did on the last problem, which is to do, keep doing that, log 6,000. All right, so we can do log of 6,000 gives us 3.778. 5 tells the 1 to get bigger, so 3.7782. So that equals 3.7782. Is that right? Yeah, 7782. Okay, so it says write the following in the form 10 to the x, where x is correct to 4 decimal places. So that means 10 to the 3.7782 equals 6,000, and that's what they're looking at. That's what we're looking to do. Okay? Okay. Last one to look at here is number 12. It says use the formula in the earthquake above, formula in the example above, to find the magnitude of an earthquake which releases 6.2 times 10 to the 13 joules of energy. So here's our formula here. And let's see, E joules of energy given by M, and then the magnitude is the M. Okay, so there's the joules of energy. That's going to be the E. So for A, we're simply going to do, not equals, but M equals 2/3 log of 6.2 times 10 to the 13th all over 10 to the 4.8. Okay, so we got to calculate that out, which is Looks a little ridiculous, but that's okay. We can figure that out. Okay, so we're going to do 2 divided by 3, and then we'll do log. Now this is where it might get a little tricky. I'm going to do another set of double parentheses here. So I want this inner parentheses to be my 6.2 times 10 to the 13th. And I'm going to close that parenthesis. Oops. Let's see. I really want to get that out. There we go. So I'm going to close that parentheses. And I want to have that divided by 10 to the 4.8. And then close that parenthesis. So it's going to take this whole thing divided by 4.8, and it's going to take the log of all of that and then multiply it by 2/3, just like what it says there. So if we push enter, we should get our right answer, I hope, 5.99. Let's see, that's going to be the magnitude. So basically it's about a 6.0 magnitude. Okay, so magnitude is about a 6.0. All right. Okay. For part B, energy released by a magnitude 5.1 earthquake. So we got 5.1 equals 2/3 log of E over 10 to the 4.8. Okay, so now this is a big fat mess. But good news is we have our graphing calculator, and we can simply put this into our graphing calculator here to figure out where these two graphs are going to meet. So I'm going to do y equals, and let's do 5.1, and then we want to know when that equals 2/3 of log, and then we'll do, let's clear the rest of that out. Oh, I cleared the whole thing out. That's okay. 2 divided by 3 log, and then I already got the parentheses, and that's going to be E, which is our variable, so we'll just put X divided by 10 to the 4.8 power. Okay, oops. Delete that, move this over so our parenthesis looks better. There we go. And now it should do 10 to the 4.8 before it does the division. So this should be okay. All right, now graph. Let's just cross our fingers that these two are going to show up in a reasonable spot on our graph. Oh, look, there goes that. Ooh, that's going way out there, isn't it? Oh, guess what? That's 6.2 times 10 to the 13th. So this is going to end up crossing way, way, way out there. So we're going to have to come up with a better way to do this. Okay, so the way we're going to have to do this is using the numeric solver, which I did in the notes, which I had already forgotten about. So my apologies. So here's what we do: math, and you got to go all the way down to C, which says numeric solver. So keep scrolling down, A, B, C, numeric solver. So we push enter, and then we're going to put our two equations in here. So look, I did a magnet. We already did one similar to this earlier. So instead of 6.9, we're going to put 5.1 in there for the first part, and then we've got the 2/3 log of x divided by 10 to the 4.8 power. Okay. Now over here it says okay, so I just got to push this. Okay. And then x equals 10, and now I'm going to push solve. I don't even know what the whole x equals 10 business is talking about, so that's okay. Because we push solve, and then it's going to tell us x equals this here. So let's go with 2.82. So we're going to go 2.82 times 10 to the, and now we got to count the number of decimal places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times 10 to the, oops, not 10th, but 10 to the 12th power. That's how many joules of energy a 5.1 magnitude earthquake should release. Okay. So again, pretty important to be able to have a graphing calculator in order to figure these out. If you have any further questions on any of this, please feel free to ask. Thanks.